let's do a couple problems from our textbook to practice the relative frequency approach to calculating probabilities. These problems come off of page 155. So I actually want to start with number 22. And in number 22, we're going to be able to define a new term. Cash. In a circle survey of 3,000 adults, it was found that 17% of the respondents do not carry any cash. Based on these results, what is the probability that a randomly selected adult carries no cash? Does it appear that most adults carry some cash? Well, we're thinking about the relative frequency approach here because we have a survey of 3,000 adults. This is a trial over this is a procedure conducted over a large number of trials. I have a big sample and we ask them all the same question. And what we find is that there's a chance of 17% stated here, so that's our probability. The probability that an adult carries no cash. And then we're asked, does it appear that most adults carry some cash? This makes us think about a different probability. Well, what I'm thinking about is that these are opposites. I either carry no cash or I have some cash. And in probability, these opposites are called complements. The complement of event A are all of the ways event A does not occur. We even get a special symbol for that. The complement of A is called A bar. And there's a nice fun fact that if I take an event and its complement and I add their probabilities, if I take the probability of event A and add the probability of event A bar, then I have to get 1. Because A and A bar are opposites. A is an event, A bar is all of the ways that it doesn't occur, so the probability has to add up to the total possible 100%. So, in a probability question about a complement, it's actually easy to find an answer. Because the probability of the complement has to be 1 minus the probability of the event. Because these two things have to add up to 1. Just imagine taking that to the other side using addition. I have that statement I just had. So here, the probability of some cash, well, that's going to be 1 minus that 0.17, or 0.83. The probability that an adult carries some cash is 0.83. Casually, or colloquially, we could say 83% of adults carry some cash, which means I'm actually in the smaller group. I don't usually carry any cash, so I guess I'm one of the 17% of adults that doesn't carry cash. 0.83 do. Question here in the book, does it appear that most adults carry cash? Yes, it does. 83% of adults carry cash. All right, well, that was problem 22 on page 155. I also want to take a look at problem number 26. In a recent year in the United States, 83,600 passenger cars rolled over when they crashed. And 5,127,400 passenger cars did not roll over when they crashed. Find the probability that a randomly selected passenger car crash results in a rollover. Is it unlikely, with a probability of 0.05 or less, for a car to roll over in a crash? Small typo in the book there. Unlikely, not 0.5 or less. We don't want to have almost a 50% chance of something happening. To be unlikely, we have a threshold of 5% or less, 0.05. So we've got a couple important things going on here. We have 83,600 crashes that did result in a rollover, and just over 5.1 million that did not. And then we're asked to calculate the probability of a randomly selected passenger car resulting in a rollover. All right, well, this is a relative frequency approach problem because we're basing this on a giant sample of things. And to be able to do this, we're going to have to actually add these two numbers together because that's the total number of trials. Now, I've started the video here without putting a calculator next to me, so we're just going to have to do this the old-fashioned way. And add these numbers together. All right. So there are 5,211,000 total things in our sample. So that becomes the denominator of my probability fraction. 5,211,000. And I'm looking for the probability of a rollover, so the 83,600 goes on top. Well, this is where I need to divide that out, and we could cancel off the thousands there and then reduce our fraction. I think a decimal is the way to go here, and I don't have a calculator with me, but fortunately I do have the instructor edition of the textbook, so I'm going to cheat and say that's about 0.0160. That is a 1.6% chance. That is below the threshold of 0.05, and it does appear unlikely. If we were selecting a random passenger vehicle accident, it would be unlikely to select a rollover. Well, that's enough for now. Let me know if you have any questions.